Chapter 5, Lesson 2 is on theoretical and experimental probability. Uniform probability is a model where each outcome has an equal or uniform probability. Theoretical probability is based on what should happen. And as you probably guessed it, experimental probability is based on what really or what actually happened. What actually happened. Example number 1. The graph shows the results of an experiment in which a spinner with 3 equal sections is spun 60 times. Determine the experimental probability of spinning red for this experiment. If you add 21 plus 15 plus 24, you get 60. That is the number of times that the spinner was spun. And it landed on red 24 out of the 60 times. So the probability of landing on red was 24 out of 60. If you take the GCF, which is 12, and divide it into 24 and into 60, you will get 2/5. 2/5, which is one of the fraction decimal percent equivalents that we learned earlier in the year, 40%. So the experiment tells you that they landed on red 40% of the time. To predict how many times a spinner will land on red if it is spun 500 times, the prediction is where we set up a proportion. You want to know how many times you landed on red. Two out of 5 times you landed on red, and you want to know how many out of 500. To solve this proportion, you multiply your cross products. It gives you 5x equal to 2 times 500. Divide both sides by 5. The 5's cancel. X. 5 goes into 500 100 times. So that leaves you with 2 times 100 on top, which is 200. So if you spun the spinner 500 times, you could predict that you might land on red 200 of the 400 times based on the experiment. In this experiment, the theory would be if there were 3 colors of equal size and you spun the spinner 60 times, you would land on red 20 out of the 60. You would land on green 20 out of 60, and you would land on blue 20 out of 60. 20 out of 60 simplified by 20 top and bottom gives you 1/3, which is 33 and 3/10 repeating percent, or 33 and 1/3%. In theory, that's what would happen. What actually happened in the experiment? You landed on red more than you should have. That's how the theory and the experimental are different. One is what should have happened, and one is what actually happened. If you think of it like a science experiment, your hypothesis is what should happen, and then your conclusion is what actually did happen. Example number 2. 2 number cubes are rolled together 20 times. A sum of 9 is rolled 8 times. What is the experimental probability of rolling a sum of 9? The probability of rolling a 9 is equal to the number of times a sum of 9 occurs over the total number of rolls. How many times was a sum of 9 rolled? That is correct, 8. Out of how many times were the number cubes rolled? 20. That reduces top and bottom by 4, because you have to simplify, and you get 2/5. Back to what we talked about earlier, one of our fraction decimal percent equivalents that we should know. That's 40%. Plus, it's the same fraction percent we had on the other problem.